Okay, I'd like to demonstrate for you the ultrasonic sensor that's also connected to an LCD display. So allow me to first share the screen that shows the circuit. So let me share the screen and let's look at the document camera. All right, so let's see what we have here. We have a whole bunch of wires connected to the Arduino to the liquid crystal display, and there's quite a few wires. I'll break down the connectivity to explain what pins on the Arduino are connected to what pins on the LCD display. I'll take care of that in class tomorrow. But for now, what I'd like to show you is how this thing is actually operating. So let's stop sharing this screen for a minute, and let's actually go to the Arduino sketch. And let's share that screen. And let me make sure we have the COM port. It is connected. Let me compile the sketch and upload it to the Arduino board. And here we go. So what I'm going to do is I'm going to click on the serial monitor, and we can observe what's going here. Right now, the ultrasonic sensor is looking at an object that's roughly 27 centimeters away. And I'm going to just place an object a little bit closer to it and slowly move the object closer to it. You can see it's changing. 6 centimeters, 5 centimeters, 4 centimeters, 3 centimeters, 4 Okay, now I'm backing the object a little bit further away. Okay, so you're seeing the information displayed in the serial monitor. Let me stop sharing that screen. And now let's go back out to look at the document camera and share that screen one last time. Okay, so we should be able to, let's reposition this. We should be able to see on the LCD, it's identifying how many centimeters we're away, and I'm moving this little Dixie cup. I'm moving it closer and closer to the ultrasonic sensor. 4 centimeters, and now it's 3 centimeters, and now it looks like we're 2 centimeters away. So you are seeing the ultrasonic sensor is seeing an object, and it's sending a signal. It's pinging. It's sending a signal out to the object. It's bouncing off of the object, returning back to the ultrasonic sensor, and it's recording the distance. And that's what we're seeing on the liquid crystal display as well. Okay. Let's stop sharing the screen. Let's go back to the sketch for a second. And all right, last time, let's go share the screen and let's see if we can explain this in a little bit more detail. Okay, so this is what we have. It's an interface with the ultrasonic sensor, and it's basically measuring the distance that it detects an object. Okay, inside of this routine, we're actually making a reference to the liquid crystal library functions so that we could send information to the LCD. There's a couple of variables that we're defining here to help us identify the duration of the pulse of the signal and the distance measured in both centimeters and inches. And there's a couple of other variables defined to discuss the LCD's number of columns and rows and the amount of delay time to allow information to get displayed. We're identifying the pin that we're using for the ultrasonic sensor to do the ping. And there's a couple of other variables that are here as well. So in the setup routine, I set up some code so that we can establish the serial monitor, so we can just use that for troubleshooting and observing the distance. We set up the LCD to define it as a 16:2 matrix, and we send out a command to identify which pin is going to be used as an output, and we just send out a low to initialize the sensor, and then immediately we go into the loop and we immediately send out a high, and we wait a certain period of time. We want to wait 2 milliseconds to give a burst, a pulse from low to a high, and then we want to send it back to a low. And then after that, we want to change the pin mode from output now to input so that we can receive and return the pulse that was sent out to the object and bounces back to us. And we're actually measuring the amount of time that it takes in microseconds. Okay, so what's basically happening, the ping sensor is returning a high output pulse that gives the time that's required for that burst to echo and then bounce back to the sensor. Now, the speed of sound travels at roughly 1,130 feet per second, which converts to about 0.00113 feet per microsecond, or 340 meters per second, which converts to 0.034 centimeters per microsecond. So we actually have to divide this number by 2, since we're looking at the time that it is received. Since actually the time received is for the sound wave to travel out, bounce off of the object, and return back to us. It works the same way that a submarine is doing sonar. It's detecting an object, and the signal is bouncing off of the object and returning back to the submarine. So basically the same way that police use radar. All right. Anyway, we take this information for the duration using our calculation to determine the distance both in centimeters and do a conversion to get it in inches as well. I'm printing out the information to the serial monitor. I'm also displaying it on the LCD, and some additional things I was trying to do, and I have to manipulate this a little bit better. It's in test mode right now, is I want to either send out a high or a low to turn an LED on when we get to within a certain distance, within 3 centimeters of being in front of the ultrasonic sensor. But that code, something's not working with it, so I have to still debug that. And then after we do that, the last thing we did to get to that point where we're displaying, we set the pin mode to input so that we could receive something coming in and evaluating the distance. Then after that's done, we set the pin mode back to output. We're basically using the same pin both as an input and an output. Depending upon the mode, we're sending a signal out so that it could bounce off of the object, and then we're converting the pin to now be an input so that we can receive that bounce signal that's coming back to us. So through this loop, we're basically toggling the mode from output to input. Send the signal out, have it bounce off, have it return back to us. So it's set up as an output and an input, and it just cycles back and forth. So that's how this thing is working. Let's just go back one last time and observe what's going on with the actual ultrasonic sensor. So let's share the document camera. And once again, here we are. We are a certain number of centimeters away, and you can clearly see this object is moving closer to the ultrasonic sensor. You can see it's 6 centimeters, 5 centimeters, 4, 3, 2. Now I'm backing it out. So you can see how this ultrasonic sensor is working as well as the liquid crystal display.